We're here on the second part of 3.1. And we have a cubic that we're going to do. It says find the equation for the tangent line to the curve at the given point. Then sketch the curve and tangent line together. And we're going to be utilizing our calculator again and matching whatever the homework says. That would be what we're going to do. Okay? So I have a cubic. We're going to first verify 1, 5 is on curve. So we want y equals 5 times the 1 to the third, and yes, y equals 5. So we verify. We're good. Again, typos. I did that on a test, by the way. So once I've been stung, I got to make sure. The line wasn't even on the curve when they drew it. They all excited. All right, so now we want the slope. And we know that's the limit as h approaches 0 of f of x plus h minus the f of x all over h. Okay? So here we go. Nothing bad. A little bit math. Now, in the elegance of math, I'm supposed to do as x approaches 0 on every entry. And sometimes I'll only wait till the end. Is that okay with everybody? The elegance says I should write it all the time, and I try. I really do. But I'm so involved with my stuff. So I go 5x plus h cubed minus 5x cubed all over h. And the only problem, it's a cubic, and we do the 1, 3, 3, 1, right? So the 1, 3, 3, 1. Okay, so it's going to be x cubed plus 3x squared h, because descending order on the variable, increasing order on the h, and then it's going to be 3x h squared and plus h. Okay, so now we're going to do a little distributive property. Five, 15, 15, and this, sorry about that, and plus, make sure we can, for the notes, there we go. And of course, we're going to cancel out additive inverses, and I'm left with h's all the way through. Here we go. Everything okay so far? Math okay? Right. Thank you for checking. I'm going to have an h factored out, giving me a 15x plus 15xh plus 5h squared all over h. Because it's a factor, it can cancel the h. If it's not factored out, you cannot cancel. Just so you know, math is math. And now we're going to take the limit where h is 0. Because this is 0 and this is 0. Does everybody see that? H is 0. So I'm left with 15x. I want the slope where x is 1. So I have my slope. So our third step is to construct the tangent line. So we're using y equals m parenthesis x minus that x of 1 point plus the y1. My point is 1 and 5, and my slope is 15. So here I go. Not bad math, hopefully. Can't promise. It looks like minus 10. So what you got? All right, here we go. So we're going to enter this in y's of 2 and enter this in y's of 1. Here we go. We're going to clear out what we've got, and I'm going to put x cubed, and then I'm going to put the 15x minus the 10. And I'm going to go zoom 6. I'll adjust it after I look to see what I have. I don't need to. All right, so our tangent line is at the 0.15, and I have 1 and 10, and it's not on there. So I did bad math, isn't it? Let me see what I wrote. 15x minus 10, x cubed was x cubed. So let me look at my math again. Where did I mess up here? 5x cubed, 15 is 3, 15, 15. Oh, this is 5s. It's a distributive of 5. And this is no, but this is a 3. These are, oh, did I do something on the calculator? Oh, I forgot my, oh, man, I'm going, why did that not work? I thought I was very calm in doing my math, so I wouldn't have an issue. There we go. There it is. Double check. And garbage in, garbage out on the calculator, and your instructor put garbage in. Five and 5. There you are. Thank you. I didn't see I did that. Here's a parabola, which is the most used in our testing process. I won't give you a cubic. I will give you probably a parabola on fixing. But you will get a square root because we're going to do quick and dirties pretty soon. All right. So we want to find the slope of the function at a given point, then in the equation of the tangent line and graph. So we're going to check 3 and 1. And we get, oh, that's a 2. I know you see it. We get R11. So we checked it out. So that one's good. Our first step is done. So now we're going to do the slope. And we're going to put our function in. And we'll do a little bit math, not anything serious, thank goodness. That'll give me x squared plus 2xh plus h squared minus x squared minus the 2 all over h. And of course, we're going to cancel additive inverses. Oh, and I forgot the plus 2 on that one. Sorry about that. All right. So now I'm going to factor out an h. 2x plus h over h. Just because it's multiplication, I'm going to take the limit, and the limit is 2x. Now for the slope, we're using x is 3. Slope is 6. So now we're going to construct tangent line. Our point being 3 and 11, and our slope equaling 6. And we have our y2. All right, here we go. Test to see if Alma can enter the function correctly. And we have a parabola. Oh, I hit log. Really good. And our line was a 6x minus something, minus 7. And this one, I'm going to do zoom 6. There it is. Second calc value at 3 is 11 and 11. We're good. Is that good? All right. I'm showing you all forms of it. I've done a parabola, I've done a cubic, and I've done a radical, haven't I? Yes. And now we're going to do a rational. A rational is a little bit more math because you need normally a common denominator when you have an h there. And then we have to then take that limit. Okay, is everybody comfortable with that? Yeah. Find the equation of all lines having a slope of -3. Okay, we know because this is a rational function, it might occur in several places. Here we're given the slope is -3. And then we need the points. The points. We'll have to find x. Okay? Is everybody breathing? Okay, not anything hard. Let's find out. So we're going to first, and we don't know a point to check, so we're going to find our points. So m equals the limit as h approaches 0 for 12 over x plus h plus 8 minus 12 over x plus 8 all over h. Does everybody agree? Okay, we're going to multiply by the LCM, the numerator and denominator. Okay, so our LCM, least common multiple, is going to be x plus h plus 8 times x plus 8. Is everybody comfortable with that? Okay, so if I'm taking the argument on the top, that means this is all one term. So I'm going to multiply or distribute that LCM within that to cancel all denominators, and then I'm going to multiply the denominator by it. Now, h being 0 is cool because it's just going to be multiplying both. I just have to cancel the 8. Is everybody comfortable with that? Am I clear? Okay, all right. Don't want to, what the hell was she saying? Well, she was saying a lot of stuff. I'm going to have now, some of you know what takes place in the cancellation process, and some do not. So I'm going to go on caution. As I multiply through this term times the first term, the x plus 8 is all we get. Denominator cancels out the other factor. Is everybody comfortable with that? Then I'm going to have a minus, and I'm going to, and this is 12. I know you see it. 12, and then on this one cancels out, but that does not. And we're dividing it by this guy. And we're taking the limit. Now we're going to do distributive property, and we're going to have additive inverses here as well. And then we're going to end up with something with h's only, if I did this math right. $16.96. All right, so let's see if I do have them canceling out. The 12x and the negative 12x, the 96 and the negative 96. So we're good. I ended up with only a term with h in it. So far, let's see if it holds out, okay? All right, I'm going to cancel my h because it is a factor for the top and the bottom. So now I'm ready to take the limit and let h equal what? And this is an absolute positive context of what is a derivative of 1 over x. The derivative of 1 over x is negative. And so this is a concept that we'll be working on in section. But we get negative 12 over that. Now we need the slope is 3, sorry. All right, so I'm going to multiply or cross multiply, if you will. So it's going to be 3 times that denominator. And we do know that x cannot equal 8, right? So that would be a caveat to anything that we do in this guy. Not that it plays into it too much, but just on the offshoot. Does everybody see what I did? All right. Okay, so I'm going to distribute. I'm going to add 24. And when I do that, 24, I'm going to get 12, aren't I? Positive. And if I divide, I'm going to get a negative 4. And I only get 1. All right. So 4 is not negative 8. So we know it exists on the line. But now we need to find that point. All right. Okay. So we know our slope Now we want f of -4. And I get a +3, right? So now I know my ordered pair is -4 and 3. And we can double check that. So if I put a -4 here, yes, it works. So we're good. Now we do the equation of the line. I get this guy right there. And what are we going to do? Now, we're going to check it. We have to graph it. And now you all are going to be selecting one from the 4 that they list. And but we want to check it. Here we go. And I have 12 divided by open parenthesis x plus 8 parenthesis for my first function. And then I have a -3x minus that 9 for my second. And I look to see I didn't forget something. I'm going to do a zoom 6 because my point is -4 and 3. A zoom 6 should do it. There it is. Now it looks like it goes through, but it is, we're only looking at a tangent point at this function. Done. Is everybody comfortable? All right. I'm going to stop right there. And I want to talk about our project. So we'll start here Thursday. Questions or comments on anything I've done on tangent lines? The math. The math, it's okay? All right. So I'm going to